Hello guys, we'll be proving the standard formula for integration of root a square minus x squared dx is equals to, well, this right here. You can just read it out on your own, and I'm giving you guys the hint to use this formula right here, the very famous sin square x plus cos square x equals to 1. So we have to use this in this integral right here, but we want something minus x squared. And that something right here is a constant, which is a or a square, and we have 1, which can be write as 1 square. So from here we can get, well, we can get that, you can just visualize it. We can either put sin square x in right hand side or cos square x in right hand side, which gives us 1 minus sin square x, which is 1 square minus sin square x, or 1 square minus cos square x. So we can see how we can use this right here. But what if instead of 1 we have a square, like this? Because not always we're going to have just 1, right? We can have any constant over here. In that case, what we have to do is, here simply we have to multiply a square on both sides. So this is a square, I'll just distribute it right away, a square sin square x plus a square cos square x equals to a square, like this. Now from here we want a square minus x square, a function of x square. So let's put the sin square, a square sin square x to the right hand side. So we get a square cos square x equals to a square minus a square sin square x. Now what we can do is, we can see if we convert this up, we have our a square minus something, right? And we have x square a square sin square x. So just compare these two. That means we should get x equals to a sine x, but we can't use sine x again, so we can just let x equals to a sine theta. Now differentiate both sides, we'll get a cos theta d theta. So this integral becomes root a square minus x square, which is a square sine square theta, a cos theta d theta. Now from this we know that this under the root is just a square cos square x, which is just a cos x whole square. Square and root cancels, giving us a cos theta into a cos theta, so which is just a square cos square theta d theta. Now we can put the a square outside because it's just a constant. And here you don't even have to do all of this nonsense right here. Simply you can just let x equals to this a sine theta, and here take a square common, you'll get 1 minus sine square theta. Use that right here and you'll also get this back right here. Now we need to integrate cos square theta. For that we need to go into multiple angle formula. We need to know that 1 plus cos 2 theta is equals to 2 cos square theta. Since we only have cos square theta right here, that means we just need to divide both sides by 2 and we get this right here. So cos square theta is equals to 1 plus cos 2 theta by 2, but this by 2 we can put outside, d theta. And now simply this is integration, we can directly integrate this. This is just theta plus integration of cos 2 theta is sine 2 theta by 2. Now we're done with the calculus part, the integration part. Now we have to go into some logical and trigonometric geometric part. So first, what is theta? We need to put back into the x dimension. So from here, theta will be equals to, well, I'll put it in this corner. We have let x equals to a sine theta. That means sine theta is equals to x by a, and from here we get that theta is equals to sine inverse x by a. So this is sine inverse x by a. Plus, what about sine 2 theta do? Well, it's just sine theta twice, right? So 2x by a Wrong, because sine 2 theta is 2 sine theta cos theta. Don't forget your multiple angles. So we know what our sine theta is, but what is our cos theta? Well, for that we have to move on to the right angle triangle. So if this is the angle, this is the perpendicular, this will be hypotenuse, this will be base. Now we need to use our sine theta right here. We know that sine theta is equals to x by a. But we also know that sine theta, we know it is just perpendicular by hypotenuse. And from here we get that perpendicular is equals to x, hypotenuse is equals to a. From here we can get our base, which is root over hypotenuse square, which is a square minus perpendicular square, which is x square. And from here we can also get our cos theta, which is base by hypotenuse, so root a square minus x square by a. So let's just put that down. 2 sine theta, which is x by a, into cos theta, which is root a square minus x square by a plus c. Oh, cannot forget the 2 right here. This is the most important part. I have forgotten twice, I think. And 2 and 2 cancels, obviously. And in fact, we can just distribute this a square by 2 inside. So this becomes a square by 2 sine inverse of x by a plus, well, we have a square right here and a into a, which is a square. They both cancel, remaining x by 2 root a square minus x square plus c. So this is basically that, because you can just switch that, they're both positive, and that is our proof right here using trigonometric substitution. Now you can also prove this using derivatives, or sorry, you can prove this using integration by parts, and I'm going to leave you guys for that. And I'll be proving this integration by parts in future, but not now. And if you learn something new, please like and subscribe. Thank you.